Hi everyone, welcome to the project demonstration of CSE564 visualization final project. We are group number 12. I am Naman Banati here with my friend Shalin Shah, and we have made a project on analysis of shooting incidents that have occurred in New York City over the past few years. So we chose this topic because shooting incidents are a real problem that the world faces today, and we wanted to analyze and visualize real world data so that we can gain insights on how these incidents happen and how we can reduce them and what precautionary measures we can take from these. So moving ahead, my friend Shalin would share how we sampled and filtered our data from the original data set.
So yeah, hello there. So as Naman said, how we sampled and filtered out our data. So I'll just show you the basic data that we use first of all. So this is the actual data that we selected for this particular data set for this particular project, and it had multiple number of columns with multiple missing values and zero values, which were redundant as well as which are of no use. So what we did is basically just remove the null values first of all, and then so these are the number of columns. So as you can see that latitude and longitude, they are in the indent, like they are first bifurcated into different columns, and then they have been combined and merged into one particular column. So it's of no use. So what we did is we curated this particular data set, and we came up with this refined data set through random sampling, and by replacing various categories of a particular attribute, since like the suppose as you can see over here, the race attribute. So it had, first of all, it had uh, yeah, so first of all it had this specific uh, part of the particular race, Hispanic. So what I did is I just generalized it first of all, and made it as one category. This would help us visualize the data more easily. So this was the part that we played in the data preprocessing. Now Naman will further demonstrate about the dashboard that we have created.
Okay, moving on, we have this dashboard over here in which we have used five different visualizations to visualize the data we took from New York City shooting incidents data historic, which we took from New York City Open Data website. And we made these five visualizations. So on the bottom right, we have this time series analysis chart, which shows the variation of shooting incidents over time. So you can simply change this slider over here, and this changes all the other four charts uh, and the data in that. So the data in all the other four charts would be of that data which is present in this time slot. So we have the data from 2006 to 2019 in this particular data set, and we can filter out that data or filter out that data to see how the variation of shooting incidents changed over time. As we can see, shooting incidents have generally been reduced over time from 2006 to 2019. Then we have this tile which shows the statistics of the number of deaths and injuries caused by these shooting incidents. These also change with the variation of the data set. So you can simply slide and see how many deaths were there in a particular time frame. We also have a PCP plot or parallel coordinate plot over here, which shows the variation, how these parameters, how five parameters vary over time in this data set. So we can further filter or brush over these uh, relations and can filter relations that we want to observe. So if I want to see a relationship between the number of murders and the age group of a perpetrator or the person who causes these incidents, we can filter out these. So I only want to see murders, not injuries, and I want to see perpetrators in the age group of say 18 to 24, and then I can sort them according to race. And if I want to see victims that fall in a particular age group, say 65 plus, I can filter this, and we can observe this trend that most of the victims in that particular race were also of the same race that the perpetrator were. So we can derive these observations from these two particular charts. Now my friend Shalin would share how the other charts help us in visualizing and gaining us insights into the data.
So yeah, moving ahead, here we have this fluoropath map of NYC precinct, which shows the intensity of the particular precinct based on the frequency count of the shooting event occurred in that particular precinct. So as you can see that the precinct name 75 has the maximum recorded number of shooting events. The second best is the precinct number 120, and so on. So yeah, this particular donut plot shows four different attributes, wherein the boroughs of the NYC, the perpetrator's race, victim's race, and the jurisdiction. And this radial bar chart shows three different attributes: perpetrator's age group, victim's age group, and the victim's race. Here, victim's race has been repeated again just because to analyze it with respect to the perpetrator's race as well, and vice versa. So now if I select a particular precinct name 75, so it will just filter out the data in the remaining graphs as well. So now what if I select the perpetrator's race? Like I want to analyze the perpetrator's race, and correspondingly I want to analyze the victim's race as well. So as you can see, it shows the count with respect to different race. It has been bifurcated into five different races: black, Hispanic, Asian, unknown, and white. And for the same for the victim race, they are divided into five different races. So now if I select the Hispanic, what it will show me, it will show like what number of perpetrators committed, like who were the victims for this particular uh, race. Like suppose the like this number of this number of black people were a victim to this Hispanic perpetrator. So what it shows is me the granularity at the perpetrator's level. And now what if I want to select this particular section, and it will show me the count of the race that I've selected. So this was the part where it shows the analysis at a deeper level. Now what if I want to go from the donut plot and the radial bar chart, it will show me the same thing. Like if I want to select this and then this, it will just filter out the data.
Okay, moving on to the insights we gained from these visualizations, we saw that the total number of shootings decreased over time from 2016 to 2019 gradually, and we also observed that most of the shooting incidents occurred during the summer and the fall season. So we iterated over the time series plot by moving the slider, and we saw that most of the incidents were in these two particular seasons, maybe because people moved out more frequently then. And then the highest number of shootings were in Brooklyn, which accounted for more than 50% of all the incidents that were in the data set. And then we saw that most of the perpetrators were of the age group of 18 to 24. So this helps us in making a target group for maybe better educating them of their duties, and maybe gaining more insights on what causes these incidents to happen and how they can be reduced. And then we found out that most of the victims were of the age group of 25 to 44. So we can take steps to help them being injured, or we can take steps which can help them prevent suffering from these incidents, maybe help them in giving out instructions on which area is more dangerous at a particular time. And then we saw that of the total incidents, there were about 20% fatality rate was there. We also observed that for housing, most safe place were Manhattan and Staten Islands, and the most dangerous place in terms of shooting incidents been happening is Brooklyn. So with that, we conclude our presentation. Thank you for watching.